Okay, so let us quickly conclude the introduction to modulus. Okay, I will not go to very difficult questions because these lectures are meant for foundation students only. So what have we learned so far in this introduction to modulus? Number one, if let us say I write mod of x equals 0, okay, it means that x is equal to 0. Another thing, that mod of x is always greater than or equal to 0, right? And mod of x can never be less than 0. All these three things are what we have learned in this lecture. Another thing that we can say is that mod of x is equal to negative x mod. Okay, these two are one and the same thing, because what we have learned as a definition of mod is that mod of x is equal to x if x is greater than 0, 0 if x is equal to 0, negative x if x is less than 0. Now when I say negative x, what kind of number is this? Is this a positive number or a negative number? This is a positive number. This is a positive number because x itself is negative. So negative of something which is already negative will give me positive. And here I have mentioned that x itself is negative, so negative of x is a positive number. Okay. And even if I write negative of x here, the similar logic will work, and you will see that mod of x is nothing but equal to mod of negative x. One more thing that we have learned in this lecture on introduction is that mod of x equal to 5 can be interpreted geometrically as distance of this number x from 0 is equal to 5. Hence, such number x can be negative 5 or 5. Okay, because negative 5 is at a distance of 5 units from 0, and similarly 5 is at a distance of 5 units from 0. Okay, let me take something else. If I write, let us say 5 plus mod x, 5 plus mod x, let us say less than 0. Okay, can it ever be true? It can never be true, because the minimum value it is going to have is 5, as the minimum value of this here going to be 0. So 0 plus 5 is the minimum value. That means this expression has got minimum value of 5. Okay, so from this, if I let us say write mod of x minus 1 plus 2 equal to 2. Now you see, I've got 2 and I have added something into this 2, and the result should be 2. Okay, so this expression here will definitely be equal to 0 for this equation to satisfied, and this will be 0 at x equal to 1. So the solution to this equation is x is equal to 1. Okay, let us say I take mod x minus 1 plus 2 modulus equal to 1. Now you see, on the right hand side I have got 1, and what I've got inside this modulus sign is 2 plus something non-negative. 2 plus something non-negative. It means that the value of this modulus will always be greater than or equal to 2, right? It will never be lesser than 2, so it can never be equal to 1. Hence I can say no solution for this equation. Okay, no solution. So if I write a question like this, let us say mod a1 plus mod a2 plus mod of a3 and so on plus mod of an equal to 0. Now you see, right hand side is 0, and for the left hand side to be 0, see, every term of the left hand side is greater than or equal to 0, right? It has to be greater than or equal to 0. It has to be non-negative. So for the right hand side to be 0, every term here should be 0 independently, right? That means a1 equal to a2 equal to a3 equal to a4 equal to an. Every term should be equal to 0, right? a1, a2, a3, all of these should be equal to 0 for this equation to satisfy. Otherwise there is no other way, right? Because every term is a non-negative term, right? So the minimum value that every term is going to have is 0, and the right hand side is 0. So 0 plus 0 plus 0 plus. So this is the only solution, that a1, a2 up to an, all of these have to be equal to 0. Okay, let me clear the page. Next thing that we learned was, let us say mod of x minus a is less than b. So how to interpret it geometrically? That I need a real number x which is at a distance of b less than b units from this number a. So to visualize it, let me say that this is the number a, okay, and I will go to a distance b units to the right hand side and to the left hand side, right? So when I go b units to the right of a, I will reach at a number a plus b, okay, and when I go b units to the left of a, I will reach a number a minus b, obviously, because on the left hand side it keeps on decreasing, right? On the right hand side it will keep on increasing. Now when I say mod of x minus a is less than b, that means the distance, I am looking for a number x, the distance of which from a is lesser than b. That means this point x can be anywhere between a minus b and a plus b, right? Because the distance of this point or this point, any of these points from a is going to be lesser than b units. Okay, so the solution to this inequality is that x lies between a minus b and a plus b. X lies between a minus b and a plus b. So if I ask another question, that mod of x minus a is greater than equal b, now for it to be greater than or equal to b, let us say I have got a point here. Now this point is at a greater distance than this b units, right? So anything beyond a plus b or anything before a minus b will satisfy this, and there is an equality also, it is greater than or equal, right? So a minus b and a plus b will also satisfy. You can put a plus b here, a plus b minus a will become b, so that will satisfy it. So hence what I can say here is anything lesser than a minus b, that means x can be anywhere between negative infinity to a minus b with closed bracket, because a minus b is also a part of the solution, or it can be beyond a plus b, that means a plus b up to infinity, right? Here and before a minus b. So the solution to this inequality is this one. Okay, so let me clear the page. Let us take another question. 3x minus 4 modulus is equal to 1 by 2. Okay, so one way of thinking about it is geometrically that we have learned. Another way is by the basic definition. Basic definition means when I say mod of x, it is equal to x 0 or negative x when x is greater than 0, 0 when x is equal to 0, and negative x when x is less than 0. So I can say that mod of x minus 3 is equal to x minus 3 when x minus 3 is greater than 0. That means x is greater than 3, right? It will be 0 when x minus 3 equals 0, that is x equals 3, and it will be minus of x minus 3 when x minus 3 is negative, that is x is less than 3. Okay, so I've just used this basic definition to open this. All right, so this is one of the ways of solving it. Let us try this way first, and then we will look at the usual geometrical way that we have learned so far. Okay, so to open this, if let us say 3x minus 4 is greater than 0, one of the cases can be this, right? That means x is greater than 4 by 3. If this is the case, then this will be 3x minus 4 equals 1 by 2. Okay, so in this case 3x will be equal to 4 plus 1 by 2, that is equal to 9 by 2, and x will be equal to 9 by 6, that is 3 by 2. Okay, so this is the first scenario, and the second case will be when this is lesser than 0, 3x minus 4 less than 0, right? It means when x is less than 4 by 3, then I can open this bracket in this way, negative of what is written inside it. So it will be negative of 3x minus 4 equals 1 by 2, right? When the expression written inside it is negative, then the bracket will, then this modulus will open as negative of 3x minus 4 equals 1 by 2, right? So minus of 3x plus 4 is equal to 1 by 2. So I can say 3x is equal to 4 minus 1 by 2, okay, which is 7 by 2, and x will be equal to 7 by 6. So my solutions are 7 by 6 and 3 by 2. X is equal to 7 by 6 or 3 by 2, right? So this is the one of the ways people solve these questions. Okay, they open the values of this modulus according to the definition of modulus. But we have learned another way, which is geometrical way of looking at it. So if I just rewrite this modulus as, if I take 3 as common, let us say, and write it like this, equal to 1 by 2, and I can simply see that distance from 4 by 3, thrice of distance from 4 by 3 has to be equal to 1 by 2. Or another way of saying it is that if I take this 3 here, I can write it 1 by 6. Distance from 4 by 3, I am looking for a number, the distance of which from 4 by 3 is equal to 1 by 6. So I will go 1 by 6 to the right and 1 by 6 to the left of 4 by 3. So when I go to the right, I will add 1 by 6 in it. That means 4 by 3 can always be written as 8 by 6, right? So it will become 9 by 6, that is 3 by 2. Okay, when I go 1 by 6 to the left of 4 by 3, the number that I'll get is 4 by 3 minus 1 by 6. Again, I will write it as 8 by 6 minus 1 by 6, that is 7 by 6, right? So geometrically, we could have solved it without even using the pen and paper. And the answer that we have got here is 3 by 2 and 7 by 6, which is nothing but the same answer that we got through the conventional approach. All right, so these are the things that I wanted to highlight in this chapter of Introduction to Modulus. I hope for the foundation purpose, that is for the class 9th and 10th, it is enough. If you know this much, then it will be very easy for you to solve questions related to NTSC. You can deal with questions related with Olympiads, etc. And we can take this discussion further in class 11th and 12th, for which I will make separate videos. All right.